So hello everyone, welcome again to my YouTube channel. So for this video, we would like to use Excel solver and goal seek in solving differential problem. So we have the optimization problem, the solving system of linear equation, and also the problem using goal seek. So for the first problem, which is optimization problem, we have a problem of a shipping company has the capacity to move 100 tons of cargo per day by air. The company charges $250 ton for air freight. Besides the weight constraint, the company can only move 50,000 feet cubed of cargo per day because of limited volume of aircraft storage compartments. The following amounts of cargo are available for shipping each day. So we have this cargo 1, 2, and 3 with the available weight per tons, which is in tons, and volume, which is in feet cube in ton. So the objective is to maximize the profit for the shipping company. So we have this decision variable. We have x1, x2, and x3. So the assuming values are 0, 0, 0, and also our objective of this problem is to maximizing the profit of the shipping company. So our given formula, which is 250 times the x1 plus the x2 plus the x3. So we must find the value of each constraint using the working equation, this one. So we have equals, so 250 times the value of x1, which is this one, times this one, the value of x1, value of x1, then the value of x2, which is the value of x2 is times the value of this one plus the value of x3, which is this one, and times this one, so equals 0. So click this and drag down. So the value for now is all 0. So since our objective is to maximize the profit of the shipping company, we will now use the solver. So by changing the variable of x1 to x3, then click, then add, then the constraint, which is the total of the each constraint, and also the which is less than or equal. So the constraint is this one, the value of this one, and then click OK. Then solve. So we have now the maximum profit of 200 24,218, and also the values for the x1, which is 30, x2 is 16.875, and also the x3 is 50. So for the second problem, we have this system equation. So we have finding the system equation using the solver function. So we have this equation of 2x plus 4y plus 5z minus 33 is equal to 0, 6x plus 6y plus 7z minus 70 is equals to 0, and also 3x minus 6y plus 4z plus 71 is equals to 0. So here's our system equation. So we have this decision variable, which is x, y, and z. So we assume that the value for x, y, and z is equals to 0. So to finding each constraint, this one is, so in constraint 1, to find the result, we would like to use this first equation, the 2x plus 4y plus 5z minus 33 is equals to 0. So we have result is equals 2, which is our x, times our value of x, which is 0, and then multiply by x, the value of the x is equals to 0, then plus the 4, which times the value of y, which is 0, then plus 5z, which times the value of y times the value of z is 0 minus 33. I know, but it's not minus 33, which is equals to 33. So we would like to put $sign before and after of Q. And also in between and after of the 0, IO rather, and also in P, put the $sign. And then click 0 and drag down. So we have the result of 0. So for this one is, we would like to use solver to find the condition to be equal. So our objective in this problem is to find the condition of to be equal. So we have the changing variable cells, which is the x, y, z, which is the values of that one, and also we have, then after that, then add the constraint, which is the result, then click and then equal sign, then constraint is to find the condition of that one, then okay, then click solve. So as we can see that our result is equals to the condition, so that's the solving system of linear equation. And by the way, also the value of x, which is should be 6.0000307, and the value for y is 11.5, and also the z is -5. So the next one is solving a goal C. So we have this problem. So we have to find the specific volume of N-butane at 500 Kelvin and 18 atm using the rate equation of state. So we have this equation of a Reed-Lake-Kwong equation, this one, and also we have this, the value of A, and also the value of the reduced temperature, and also the critical temperature, and also we have the value for this one. The value of R is 0.0206 atm gram mole Kelvin. So this one, so we have this Reed-Lake-Kwong equation. So this one is from the equation, this formula. So we have also A where we can use to the further solving this equation, and also our B, which is this one. This is the formula. So where our X is equals to this one, and also the reduced temperature is this one also. So solving for A and B, this one. So we have also this given. So we have this given for temperature. We have 500 Kelvin. The pressure is 18 atm. The critical temperature is 425.2 Kelvin, and the critical pressure is the 37.5 atm, and also our radius, which is constant, 0.082061. So for this one, is our objective is to determine the specific volume of N-butane at a given condition. Our value for TR is, meaning pa ng TR? Ilan? Temperature. So this is our value for the TR, which is the reduced temperature of 1.1759. And also we can now solve the alpha, which is the X, and distribute the given value. So we have the reduced temperature, which is 1.1759 raised to 0.5. 0.5, then click enter. So our value for alpha, which is the X, is 0.9222. Then solving for A and B, which is our alpha, A, which is our formula for A, is this one. So substituting for R, which is the 0.082061, and also our critical temperature, which is 425.2, this one, and also our critical pressure, which is 37.5. So also the value of X, which is 0.9222, then click enter. So we have the value of A, which is 12.79841771. So for B also we have this one. We have this formula, this one. So click that one, then paste, then distribute the value for R, which is 0.82061, and also the critical temperature, which is 425.2, and also the critical pressure, which is 37.5. Then click enter. So we have the value for B, which is 0.08061526. So assuming that the volume of N-butane is an ideal gas behavior, so we can use this equation PV is equals to RT, where V is the specific volume. So solving for V is equals to RT over P. So therefore substitute the value for R, which is 0.082061. Then the temperature is 500 Kelvin. Then the pressure is 18 atm. Then click enter. So we have the value for V, which is 2.27947222. So using our initial value, so our value for V is 2.9795. So using the Redlich, so using the Redlich equation, we can solve the V, which is the formula of this one. So copy for that, then paste it, equals paste. Then our value for V is the 2.9795 times the pressure, which is 18 atm, times so the value for V is our 2.9795, and also the value for R is 0.082061. Then the temperature is 500 Kelvin. Then the V, which is 2.9795. Then our A is 12.7984171, and P is 18 atm, times the value for B is 0.08061526, times the value for T, which is 500 Kelvin, and also the B 0.08061526, A, which is the yes, then B 0.08061526. Then click enter. So we have this answer. So from this one is we would now use solver. So go to what if.
Go.
By the way, goal seek pala yung gagawin natin to solve this problem. So go to what if analysis, then goal seek. We have goal seek. So to value is 0. So by changing cell, which is the value of V. So by changing cell is using the initial value of V. Then press OK. So So the value of V using the Archi equation after we use Gaussian is 6.30625 E dash 06. So while the value of initial volume is this one, 2.03771367. So yun lamang po. Maraming salamat.